Hey guys, welcome back to another Algebra 2 video. In the last video, we talked about slope intercept form. And that was a form of linear function, so a line, in which you had the slope visible and the y-intercept visible. And we could also call this mx plus b form, as it's often shown. And in this form, the number by itself out to the right was your y-intercept, which means that's where the number goes on the y-axis, and that gives you your starting point. And then the number in front of x, the coefficient, gives you the slope, which is how you're going to get to the next point from any given point. So in this case, it would be 3 over 1, so I go up 3 and over 1. And that's what we did to graph our lines. But this is not the only way to graph a straight line. There are other ways to do it, and we're going to learn a different form, a more powerful form. You see, with slope-intercept form, you have to have a y-intercept that's easy to graph, and that's not always the case. What if you had a line that crossed, say, in the middle here, or somewhere odd? It wasn't on a whole number, or maybe your y-intercept happened to be very, very large. Maybe it's a line that looks like this, which is easy to graph, but if you'll notice, the y-intercept is going to be really, really high off this graph, and I'd have to make this way larger to find that point really high. There are some major drawbacks to this slope-intercept form. So we're going to learn a new form, and we're going to call it point-slope form. Oh, that's not how you write slope. Point-slope form. Now, I do need to make a quick side note. What I'm going to be teaching here in this video is a modified version of point-slope form. So if you look up point-slope form in a textbook or something like that, it's going to be slightly different than what I'm showing. I'm going to leave a description, an explanation of what I mean by that in the description of this video. So if you want to see why that is, go do that. But for the purposes of my students and what we're going to be doing, we're going to be using this modified version. Okay, anyway, with that out of the way, let me just show you an example of what point-slope form looks like. Y equals 2x plus 3 plus 1. So right off the bat, you'll notice that this one looks more complicated. It's got some parentheses in it. Now, without explaining why this works and getting into the theory of graphing and all that kind of stuff, I'm just going to show you how to graph the thing, and just to show you how easy it is, because I don't want this to get bogged down in a lot of theory. So what we're going to do is notice that the first number is still the slope. So that number out front, in front of the parentheses, is still the slope. Next, what we're going to do is we're going to notice that there's a number in here with the x. The number in here with x is going to be associated with x. And what I'm going to do is change the sign of whatever that number is. Right now it's a plus 3. That means it's a positive 3. So I'm going to change that one to a negative 3. I'm not going to go over why right now. I'm just going to do it. And this number on the outside, I'm going to write it down next to it, but I'm not going to change its sign. So the number in parentheses I'm going to change. The number outside the parentheses I am not going to change. Okay? And those two numbers are going to give me a coordinate. They're going to give me a point, a starting place for my line. So this coordinate, this is not a slope, this is an actual point in 2D space, is going to be located at negative 3, 1. This is the x and this is the y, remember? So I'm going to go left 3 and up 1. I said it like a slope, left 3 and up 1, but it's not a slope. I'm just telling you how to get to this location on the plane. This is where the coordinate negative 3, 1 is. That's not 3. Let me write that again. Negative 3, 1. And then I'm going to go up 2 over 1 as my slope dictates, just as I usually do, but I'm going to start from this point instead of a y-intercept. Or I can go down 2 and left 1 just like before. It works either way. And it's really that simple. So the slope is the same, and instead of using a y-intercept, we're just using a point. Now, if you notice, Our y-intercept on this particular problem is way up here. It's 1, 2, 3, 4, 5, 6, 7. Our y-intercept is 7. This number out here by itself is not 7. So when you see functions in this form, you might be tempted to think that that last number is still the y-intercept. It is not. That is the y-coordinate of our point. It is not actually the y-intercept if it's not in slope intercept form. Okay, let's just do a bunch of examples and get really good at this. Here's another one. Now, if you think you've got this, I suggest pausing the video and giving it a shot, and then come back and we'll do it together. All right, so my slope, or m if you will, is going to be 1/3. And my point, I'm going to change the sign of the one in there with the parentheses. So that's going to be +2. I'm not going to change the sign of the one outside the parentheses. That's going to be 3. That gives me my coordinate, 2, 3. That point is here. This is the point, 2, 3. You don't always have to label yours when you're doing work for me, but I'm going to label it for you here on the graph so you can see. And now, actually, knowing where this line's going to go, maybe I should, well, I think it was in the right place. That'll work. All right, now my slope tells me to go up 1 and over 3. So from this point, up 1 over 3 would be here, and then down 1 and left 3 would be here, and here. And again, I get my nice straight line. Very, very simple. This isn't, I don't think, any harder than slope y-intercept form, but it is more powerful, as we're going to see in a few minutes. Let's do another couple of examples before we jump into other things you can do with this. Why don't you try this one on your own really quick? All right, I'm assuming you've tried it. This one looks a little bit different. Notice that there's no number out here, but there is a number in here with the x. That's okay. I want you still to think about this as a pattern. So the first number is your slope. The point is still going to come from the same places. The number in there with the parentheses is still going to give me my first one. That's a -3. The number outside is still going to give you my second number. But there's no number outside. So what is the number for nothing? 0. So if it makes you feel better, you can put a +0 there. It just tells you what that y-coordinate is going to be, y component. So my point is -3, 0. If I go over here to my graph, that is here. And then I have a slope of -2. So -2 over 1 means I go down 2 and right 1, down 2 and right 1, or up 2 and left 1. And I get, again, my straight line. So that's how you would deal with something if there's not a line, or excuse me, a number out to the right. It's just 0. Okay, maybe one more. All right, try that one real quick. Okay, so my slope, m, is -3/4, and my point, I'm going to change the sign of the one inside, which is -1 already, so it's going to be 1 now. I don't change the 5 because it's on the outside, so my coordinate is 1, 5. Change colors. 1, 5 would be here. Be very careful when you're plotting these points. In class, students will make mistakes all the time, very simple mistakes, and they'll switch up the x and the y and put that coordinate in the wrong place. So just be very careful. So that's where 1, 5 is, and then our slope of -3/4 is going to go down 3 and right 4 from that point. And I'm just going to draw one of them. That should be sufficient for this one. And then you draw your line, and you get your linear function, your graph. All right, now let me show you one of the reasons why this is so powerful. Let's say you were given, let me go to a page doesn't have a graph on it. Let's say you were given a slope, and you were given a point, and you don't know anything else. You don't know You don't have a function, you don't have a picture, nothing, but you know the slope, and you know that somewhere along that line is the point 3, 4. That's all you're given. Well, if you remember, both of these pieces of information were pulled out of that last form that we just used. So if you just reverse those steps, you can place them back into that form. In other words, I can use just this information to create an equation. So I had y equals, the slope went first, I had parentheses, I had an x, I had a number in here, and then I had another number out here. So it's just a matter of reversing those steps. Remember, the slope goes in the front, so I'll just put the 2 here. And when I pulled the number out of this spot to make the coordinate, I always had to switch the sign. In other words, when I went from here to here, I had to switch the sign. So this point has an x coordinate of 3. That means that this must have been a -3 when it was in here, right? And I know that I'm never going to change the number or the sign of the number outside. That means this 4 didn't change. So it's going to be a +4 still. Make sure you put the plus sign. It's not just a 4, but it's a +4. And now we have created an equation for a line simply by having a slope and a point. And this will work with any slope and any point, and you can write an equation for it. Let's do another one. Y equals 3/4, and my point is, let's say, -2, 6. All right, try this one really quick, and then come back and see if you got it right. All right, just like the last one, I'm going to write my slope first. It's 3/4, parentheses, x, that's always the same. I'm going to change this sign because it came from in there with the x coordinate, or with the x variable. So I'm going to add 2 because it's a -2. And then remember, the 6 comes from the number on the outside that was not changed. So I put +6. And it's really as simple as that. That's all you have to do. Okay. Now, being able to do things like this also gives you a really powerful tool for working with parallel and perpendicular lines. So, for example, let's say I was given a line. Let's say it's y equals 4x plus 1. So I'm giving you a line, and I want a new equation. So write the equation of a line that is parallel to this. Let me actually rewrite that. Parallel to y equals 4x plus 1. And it goes through a point, some particular point that I give you. Goes through the point 2, 3. All right, so I've given you a line, and I want the equation of another line that is parallel to this one, but it goes through this point. All right, so in other words, here's the point 2, 3, right here. And there's going to be a line somewhere. It could look like that, or like that, or like that. The point is, it's going to be parallel to this other line. Well, I don't need to graph this other line. All I need from this line is one piece of information. And if you remember, parallel lines have the property that their slopes are the same. And that just kind of makes sense if you think about it, because they're going the same direction. So the amount that the line is sloping is exactly the same. So the only thing that I care about from this first thing is the slope. This is all irrelevant. It doesn't matter. All I care about is the fact that this line has a slope of 4. So it could be here or here or here or here. It doesn't matter where that line is. It has a slope of 4. And I know that my new line, I want to be parallel, which means it's also going to have a slope of 4. So now I have all the information I need. I'm just going to write y equals 4 because it's the same. And now I use this point here, x minus 2 because I switched that sign, plus 3 because I don't switch that sign. And now I have a coordinate, or excuse me, an equation for a line that is parallel to this one because it has the same slope, but it goes through this point. All right, let's do another one just like that. You try this one real quick on your own, just to make sure you've got it. So parallel to this one. Now, this looks a little bit different than the last one, but it doesn't matter. The slope is still visible and goes through. You could also see the verbiage or the words includes the point. So parallel to this line and includes the point or contains the point. Those are all the same. It goes through 5 and let's do a negative number. -5 and 7. All right, try that one really quick and see if you can get it right. All right, so parallel means that they have the same slope. Remember, all this garbage is unnecessary. All I care about from this first line is the slope because I want to know that it is parallel to that line. So my slope for this new line is going to be the same. It's 2/3. So I have y equals 2/3, parentheses x, switch this sign, plus 5. Don't switch this sign, 7. And we're done. That's really all there is to a problem like that. You can also take this concept and do things with perpendicular lines. So perpendicular to, let's say y equals 3x plus 1, and goes through the point. I'm going to skip some of the words so I don't have to write it all out. Goes through the point, let's not use 3. Let's do 2 and 4. Well, unlike parallel lines, perpendicular lines do not have the same slope. Perpendicular lines have slopes that are negative reciprocals. And all that means is that they are flipped and the sign is switched. Let me actually write that real quick. So I'm going to flip the sign, flip the fraction over, and then I'm going to switch the sign. So I'm going to flip it and switch it. So if I'm given a slope of 3, then its perpendicular one's going to be flipped over, which is 1/3, and negative. All right. So just to practice that for a second, if it was 2, it'd be -1/2. If it was already a fraction, we could do something like that. We could say 2/5 would then become -5/2. You could also have, I'm making a mess of this, -3/4 would then become 4/3 because I changed the sign from negative to positive and flip it over. It could be -7, and then its perpendicular slope would be -1/7. So whenever you're trying to find a slope that is perpendicular to whatever slope you've been given, whatever line you've been given, you take the slope, you flip it upside down. It's called taking the reciprocal, and then you change the sign. If it's positive, you make it negative. If it's negative, you make it positive. So back to this particular problem. If I flip 3 over, I'm going to get 1/3, make it negative. And then to use this point, I have x minus 2 because I'm switching this one, and then x, and then plus 4 because I'm not switching this one. And that's how you handle perpendicular lines. Let's do one more like that so you can practice one on your own, and then we'll keep going. All right, let's try something like this. All right, and the point is 5 and 7. Okay, so the slope of a line perpendicular to this one, I'm going to take the slope and flip it upside down. So I have 5/2, taking the reciprocal, and it was negative, so now I'm just going to make this one positive, which now it is. Now I have x minus 5, switching the x, and plus 7, not switching the y. And from here, you could graph this. That's actually a pretty good exercise. We're not going to do it now, but if you'd like to prove to yourself that these lines are in fact perpendicular, you could graph both of them and you'll see that they will form a perfect 90-degree angle. It will work. Okay. Now, let's talk about how you would move from one form to the other. Suppose you were given something in point slope form, right? Something like this, 3x plus 2 plus 5. And you want to know, you want to know what the y-intercept is. Remember, this is not the y-intercept because this is not in slope y-intercept form. It's not in slope intercept form. It's not in y equals mx plus b form, if you will. So this is not the y-intercept. It's something different. But if you want to find out what the y-intercept is, you have to put this into slope y-intercept form. Or let's say you just wanted to graph it in that form for whatever reason. So I want to change this from point slope to slope intercept. How would I do that? Well, there's a clue in that slope intercept form doesn't have any parentheses. So naturally you might say, well, if I don't have parentheses in slope intercept form, and that's what I want, how might I get rid of those parentheses? Well, you could imagine maybe distributing. So let's try that. Let's distribute this 3. I'm going to distribute that, and I get 3x. 3 times 2 gives me 6, and then plus 5. That looks closer. And then you might notice that you could combine like terms. The 6 and the 5 will come together to make 11. So now I have written this thing, which was in point slope form, now in slope intercept form. And you could graph it this way, or if you were just trying to find out the y-intercept, there it is. This is the y-intercept, and it is now visible in the function because it's in this form, that last number is the y-intercept. It's really that simple. All you have to do is distribute that slope into the parentheses with the x, and then just collect your terms and simplify. Let's try another one. You do this one. Convert this point slope form into slope y-intercept. All right, first thing I'm going to do is distribute the negative 3. So I have negative 3 times x is negative 3x. Negative 3 times 5 is negative 15 plus 2. And now I'm going to simplify. Negative 3x. This is a negative 15 plus 2. The signs are different, so really I'm subtracting. So this is a negative 13. And that's it. I have turned this function up here in point slope form into slope y-intercept form. And now the slope is still the same. That was visible. But now I know the y-intercept is negative 13. So if you're ever asked to find the y-intercept and you don't have that form, just convert it and then write that number down. Let's try one a little bit more interesting. How about this? If you think you can do this one, pause it, give it a shot, and then come back and we'll see if you got it right. All right, this actually works exactly the same way. It's just a fraction. We're going to multiply by a fraction. If you multiply 1/2 times x, it just gives you 1/2 x. If you multiply 1/2 times 8, that's the same thing as saying, what is half of 8? That's literally the same thing. So what is half of 8? Well, half of 8 is 4. It's the same thing as saying, what is 8 divided by 2? That's 4, and then minus 1. So then I get 1/2 x plus 3. And that's my answer. What if you had a more interesting slope, say 2/3 or 3/4 or 5/7 or something like that? Before we do an example like that, it might be a good idea to kind of remind ourselves how to multiply by fractions. Now, if you already are good at this, then you can skip ahead a little bit. But in the event that you're not good at multiplying by fractions, this will be a good refresher for you. Or it might be a method that you've never seen before. Let's try 2/3 times 12. When I look at 2/3, I'm going to recognize that this symbol here for the fraction is actually a division symbol. We use it for division, and that's because division and fractions are two ways to look at the same concept. This is actually just 2 divided by 3. 2 divided by 3 is 2/3. So you can think of this bottom number as the act of dividing, and this top number as the act of multiplying, since that's what we're doing. So you could just take this 12, divide it by 3, getting 4, and then multiply by 2, and you get 8. And that's how you multiply by fractions. It's really that simple when you're doing a fraction times a whole number. So whatever the bottom number is, you divide. Whatever the top number is, you multiply. You can do that in any order you'd like, as long as the bottom's division, top's multiplication, and you get the answer. Let's try another one really quick. Let's try 3/4 times 20. So the bottom number is division. So 20 divided by 4 is 5. And that 5 times 3 is 15. That really is all there is to it. It's very, very easy to do. Let's try another one. 2/7 times 35. All right, divide 35 by 7. I get 5. 5 times 2 is 10. Now you could also do this the other way around. You could do, if you wanted to start on the top, you could say 35 times 2, that's 70, divided by 7, do it the other way around. That gives you 10. So it'll work either way. I just personally like to divide first because it makes the numbers smaller, and it's easier to work with smaller numbers than bigger numbers in general. Okay, so with that review out of the way, let's go back and do a problem like that. So we could do something like this. So now if you have some kind of strange slope out front, it shouldn't be a big deal to get it converted over to slope intercept form. So we're going to distribute again. So 2/3 x. 2/3 times 15. Well, I'm taking 15 and really dividing it by 3, which is 5. And then 5 times 2, which is 10. That gives me that. So now I have y equals 2/3 x plus 9. Piece of cake. All right, let's do one more like that before we move on. Let's try a negative one. Let's do negative 4/5. Something like that. All right, you guys give this one a shot first. All right, so I'm going to multiply through with negative 4/5. The first term is just negative 4/5 x. That's easy. Now this is negative times a negative. I do have see some confusion when I teach this in class among students because this is a slope, and remember we talked about making either the 4 or the 5 negative, and it gets kind of weird when you're multiplying and dividing, and how do I do all that stuff? I would suggest just ignoring the signs for now. Just think, what's 4/5 times 30? In other words, ignore the signs completely. 30 divided by 5 is 6. 6 times 4 is 24. So just do that first. And just notice that that's a negative, that's a negative. Negative times a negative is a positive. I wouldn't try to think about, well, I'm dividing by a positive 5 and then multiplying by negative 4 or dividing by... Don't make this overly complicated. It's just a negative times a negative is a positive, so I know this number will be positive. So that's all I'm going to do with that. And then plus 6. And now I simplify, and I get negative 4/5 x plus 30. Okay, that is how you turn things from point slope form into slope y-intercept form. And the last thing we're going to do today is we're going to talk about how to convert them back over. This is more fun. So we're going to talk about how to go from something that looks like this backwards to get something that looks like that. Right? Okay, let's do one. Let's do a really, really simple one first. Y equals 2x plus 9. Now, I'm going to do a side one real quick. If I were to do y equals 2 times x plus, 3 plus 3, and I were to work that out, 2 times x gives me 2x, 2 times 3 gives me 6, and then the 3. Notice that when I simplify this, it'll give me what I'm looking for, 2x plus 9. This 9 came from these two numbers, right? So if I can find a way to break the 9 back into two numbers, that's a good start. And also notice that this 6 right here, let me zoom in a little bit, this 6 came from multiplying these two numbers. So if I were to divide 6 by 2, I will get that number back. Basically, I'm going to undistribute that 2. It's called factoring, and we really haven't gone over factoring yet, but if you're familiar with factoring, that's what we're doing. We are undividing. We're pulling that 2 out. We are undistributing that number. So keep in mind where this came from, because this is going to be what we're going to be doing. We're just running it backwards. So going this way, I would think, okay, I got to turn this into 2 numbers. Now, they could be any 2 numbers, but the first one here needs to be divisible by 2. In this case, it was 6 and 3. So I'm rewriting this as 2x plus 6 plus 3. This is the same thing as 2x plus 9. It's not different. I just split that 9 into 2 pieces. And now I'm going to look at this part and say, can I undistribute that 2? That's a terrible way to say that. That's what we're doing. But the technical term is, can we factor that 2 out? So I'm going to divide this by 2, and I get x. And I divide this number by 2, and I get a positive 3. I have undistributed that 2. I have factored that 2. And then this 3 is still here. And now I have turned something from slope y-intercept form into point slope form. Now, I realize that might be a little bit complicated, so we're going to do a bunch more examples to get good at it. Let's try this one. All right, now if you want to try this one on your own, I highly suggest doing that first and then come back and I'll work through it with you. All right, so remember the goal is to take this last number and to break it into 2 numbers such that one of them is divisible by 3. I'm going to choose 15 and 2. Now, you could have chosen 2 different numbers. That's the beauty of this. I'm actually going to do a different one in a minute just to show you that it also works. But I'm going to use 15 and 2. You can't choose any 2 numbers. You have to choose some where the first one is divisible by 3, and 15 is. So now I'm going to undistribute that 3. I'm going to factor that 3 out of these 2 pieces. So if I put 3 out front and I divide 3x by 3, I get x. Divide 15 by 3, I get 5. And the 2 just hangs out, and I'm done. I don't think it's really that bad once you understand what's going on. It shouldn't be too difficult. Now, this is just one answer. What if you had done something different? Let me change colors so don't make this too confusing over here. I'm going to write the same problem down again. I'm going to use a different set of numbers. You could have chosen, let's say, 12 and 5, right? Because 12 plus 5 gives you 17, and 12 is divisible by 3, so you could do that. So I have 3x, divide 12 by 3, you get 4. The 5 just hangs out. This answer is also the same. It's exactly the same line. Now, to see that, the point for this one, let me actually do this. Don't let this confuse you. I hope I'm not going too far into this. This point just goes through here, and this one has a point of -4 or 5. But they both have the same slope. They're actually the same line. We're just thinking about them as starting in a different place. And if you wanted to find out, prove that they're the same, just look back at the fact that they're both, in fact, 3x plus 17. You can multiply these out, and you will get 3x plus 17 again. So the point is, it doesn't matter which 2 numbers you choose to break it apart using, as long as the first one of the 2 is divisible by that first number. All right, let's try another one. And you definitely should try this one on your own first. Okay, I'm going to assume you've tried this. So I'm going to choose some numbers to break this apart with. I could choose 20 and 2, because 20 is divisible by 4. I could also choose 16. I could choose 12. Let's use 16. You don't have to use the largest number that will go into it. You can choose whatever number you want as long as it's divisible by 4. So that's 16 plus 6, right? 16 plus 6 is 22. Now I pull that 4 out. I have x plus 4 and then plus 6. You could have done, just in case you did it this way, you could have done 20. So 4x plus 20 and then a 2. right? And then you would have gotten 4x plus 5 plus 2. Again, these are both correct answers. Both fine. There's, in fact, an infinite number of correct answers. All right, try this one. Make it slightly more tricky, I think. Okay, now with this one, you have to be very careful how you break this number up. If you're breaking up a negative number, you're going to want to use two negative numbers to do it. So let's say I wanted to break this up into 12 and 3. I'm going to use a negative 12 and a negative 3. And in class, a lot of kids will get this confused and say, well, two negatives is a positive. That's a negative. We're subtracting and adding here. So a negative 2 minus 3 is a negative 15. Right? So we're still dealing in addition and subtraction. There's no multiplication here. So whenever you break apart a negative number, make both numbers negative, unless you want to get creative and do something more complex. But that's not the goal of this. All right, and then what we'll do is we'll just pull that 2 out. Now, if you divide negative 12 by 2, you'll get a negative 6. All right, now one more quick note I'll make. I have noticed sometimes when I teach this in class, students remember that, hey, when you put things into this form, you have to switch the sign, because that's what we did at the beginning of the video, right? Switching signs back and forth, going in parentheses. Make sure that's not what you're doing here. Right here, we're just doing algebra, okay? We're just multiplying and dividing. At the very beginning of the video, we were noticing a pattern, a trick. That's why we switched the sign to go from a point to a equation and back and forth. That's why we were switching that sign of that thing. This is not a trick. This is just, or a pattern. This is literally algebra. So when you divide by negative 12 by 2, you get negative 6. Don't switch that sign. Okay. Let's do another one. How about something like this? It shows you another thing that you might run across. Now with something like this, you could break this apart and you could say, well, I need two things that give me 12, that, one of them is divisible by 3. I could do, let's do 6 and 6. Why not? Or I could have done 9 and 3, whatever. And then when I do that, I get 3x plus 2, because 6 divided by 3 is 2, and then plus 6. There's nothing wrong with that. That's perfectly fine. But notice that this 12 is already divisible by 3. So really, I didn't have to break it apart to start the division process. So instead, I could have done something like this. So I have this situation. I go ahead and factor it out. So if I divide 12 by 3, I get 4. And now I'm done. You could imagine there was a 0 out here. You don't have to write it. But this goes back to that example where there's nothing on the outside, which is totally fine. So if you have a number where you can go ahead and divide it, it's divisible by that first number, you can go ahead and do it that way, and you're already done. And now this is that form. It doesn't matter. You can do that. This will give you the point negative 4, 0 if you were to graph it. This gives you the point negative 2, 6 if you wanted to graph it. So it really doesn't really matter. I just wanted to show that to you because if that number is divisible, you could do that. And you could do, just to kind of drive that home, y equals negative 3x, let's say minus 15. Noticing, let me write that a little better. Noticing that 15 is divisible by 3, so I'll go ahead and divide by negative 3. If I divide negative 15 by negative 3, I get a positive 5. And then I'm done. Okay? And if you want, if you're unsure of how you did the signs and things, you could always multiply this back through and see if you get this, just to make sure that it works out. Because if you did the division correctly, then when you distribute, it should give you that first thing back. Okay, I think that's going to be enough for this video. We have learned how to graph things in point-slope form. We have learned how to take a point and a slope and create the equation for a line. how to work with parallel and perpendicular lines using point slope, and also to convert back and forth between point slope and slope y-intercepts. We did a whole lot of things in this video. I hope that this was instructive. I hope that you were able to follow it. And thanks for sticking with me to the end, and I'll see you guys in the next video.